Yes, so tomorrow is RWS AE exam. So ನೀವೆಲ್ಲರೂ ರೆಡಿ ಆಗಿರ ಅನ್ಕೋತೀವಿ. ಓಕೆ, ಸೊ ಈ ವಿಡಿಯೋ ನೋಡಿರಲಿಲ್ಲ ಅಂದ್ರೆ ನೋಡ್ರಿ, ವೇರ್ ಐ ಹ್ಯಾವ್ ಡಿಸ್ಕಸ್ ದ ಟಿಪ್ಸ್ ಆ್ಯಂಡ್ ಸ್ಟ್ರಾಟಜೀಸ್ ವಿಚ್ ಯು ಹ್ಯಾವ್ ಟು ಫಾಲೋ ಆನ್ ದ ಡೇ ಆಫ್ ದ ಎಕ್ಸಾಮ್. ಓಕೆ, ಸೊ ಭಾಳ ನಿಮ್ಗೆ ಅದು ವ್ಯಾಲ್ಯೂ ಆ್ಯಡ್ ಆಕೈತಿ. So the main purpose of making this particular video is regarding the confusion with respect to calculator. ಸೊ ನಾವು ಇವತ್ತಿನವರೆಗೂ ವೇಟ್ ಮಾಡಿದ್ವಿ. ಇವನ್ ನಾನು ನಮ್ಮ ಟೆಲಿಗ್ರಾಮ್ ಗ್ರೂಪ್ ಒಳಗೂ ಮೆಸೇಜ್ ಮಾಡಿದ್ನಿ ಲಾಸ್ಟ್ ವೀಕ್, ಲೈಕ್ ಲಾಸ್ಟ್ ಮೊಮೆಂಟಿಗೆ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಅಲೌ ಮಾಡ್ತಾರೆ, ಬಿಕಾಸ್ ದಿಸ್ ಇಸ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಯೂಶ್ವಲಿ ಫಾರ್ ದ ಎನಿ ನೋಟಿಫಿಕೇಶನ್ಸ್. ಬಟ್ ಅವ್ರು ಅಲೌ ಮಾಡಲಿಲ್ಲ. ಸೊ ದ್ಯಾಟ್ ಈಸ್ ದ ರೀಸನ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಆರ್ ಪ್ಯಾನಿಕಿಂಗ್ ಆ್ಯಂಡ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ಮಿ ಲೈಕ್ ಹೌ ವಿ ಕ್ಯಾನ್ ಸಾಲ್ವ್ ದ ನ್ಯೂಮರಿಕಲ್ಸ್. So today we have come up with the solution for these kind of questions where you can solve the complex numerical without using calculator. Okay na? So now when a numerical is there, ಎರಡು type of numerical ನಾನು classify ಮಾಡ್ತೀನಿ. One is like very simple numerical where you can substitute the values and get the answer straight away without doing calculation. Even the calculator is allowed. ಓಕೆ, ಸೊ ಎಷ್ಟೊಂದು ಆ ಟೈಪ್ ಕ್ವಶನ್ಸ್ ಅದಾವು, ನೀವು ನೋಡಿರಬೇಕು. ಸೊ TON ಥ್ರೆಶೋಲ್ಡ್ ಓರ್ಡರ್ ನಂಬರ್, ಆ ಟೈಪ್ ನ್ಯೂಮರಿಕಲ್ಸ್ ಒಳಗಂತೂ ನಿಮ್ಮ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ನೆಸಸರಿನಿಲ್ಲ. ಆ್ಯಂಡ್ ದೇರ್ ಆರ್ ಮೆನಿ ಸಚ್ ಎಕ್ಸಾಂಪಲ್ಸ್. ಸೊ ನಿಮಗೆ ಆ ಪಾರ್ಟಿಗೆ ಏನೂ ಈಗ ಟೆನ್ಷನ್ ಇಲ್ಲ. ಬಟ್ ವೆನ್ ಇಟ್ ಕಮ್ಸ್ ಟು ದ ಕ್ವಶನ್ಸ್ ವೇರ್ ಇನ್ ದ ಫಾರ್ಮುಲಾ ದೇರ್ ಈಸ್ ಇನ್ವಾಲ್ವ್ಮೆಂಟ್ ಆಫ್ ಎಕ್ಸ್ಪೋನೆಂಟ್, ದಟ್ ಈಸ್ E, ಲೊಗ್ಯಾರಿದಮ್ LOG ಆರ್ ನ್ಯಾಚುರಲ್ ಲಾಗ್, ದಟ್ ಈಸ್ LN. ಸೊ ಈ ಟೈಪ್ ಕ್ವಶನ್ಸ್ ನಾವು ಹೆಂಗೆ ಸಾಲ್ವ್ ಮಾಡಬೇಕು? ಸೊ ಸ್ಟೂಡೆಂಟ್ ನನಗೆ ಮೆಸೇಜ್ ಮಾಡಿದೆ ಅಂದರು, ಲೈಕ್ ಮೇಡಮ್ BOD ಕ್ವಶನ್ಸ್ ಹೆಂಗೆ ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಅಂತಂದು. ಸೊ ಯೂಶ್ವಲಿ ಲೈಕ್ ನಿಮಗೇನು ಅನ್ಸೈತಿ, BOD ಟೈಪ್ ಕ್ವಶನ್ಸ್ ಬಂದ ಕೂಡಲೇ ನಾವು ಸ್ಕಿಪ್ ಮಾಡಿಬಿಡೋಣ. ನೋ, ಯು ನೀಡ್ ನಾಟ್ ಸ್ಕಿಪ್. ಸೊ ನೀವು ಸಾಲ್ವ್ ಮಾಡಬೇಕಂದ್ರೆ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ವಿಡಿಯೋ ಎಂಡ್ವರೆಗೂ ನೋಡಿರಿ. ಸೊ ಅಂಚಿತ್ ಸರ್, ಹೂ ಈಸ್ co-founder ಆಫ್ SANPoint ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ ಅಲ್ಲ, ಸೊ ಹಿ ಹ್ಯಾಸ್ ಕಮ್ ಅಪ್ ವಿತ್ ಸರ್ಟನ್ ಟ್ರಿಕ್ಸ್ ಟು ಸಾಲ್ವ್ ದೀಸ್ ಕೈಂಡ್ ಆಫ್ ಫಾರ್ಮುಲೆ ವೇರ್ ದರ್ ಈಸ್ ಇನ್ವಾಲ್ವ್ಮೆಂಟ್ ಆಫ್ ಎಕ್ಸ್ಪೋನೆಂಟ್, ಲಾಗ್ ಆ್ಯಂಡ್ ನ್ಯಾಚುರಲ್ ಲಾಗ್. ಸೊ ವೆರಿ ಸಿಂಪಲ್ ಐತಿ. ನೀಟಾಗಿ ಅವ್ರು ನಿಮಗೆ ಎಕ್ಸಾಂಪಲ್ ತೊಗೊಂಡು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಯಾರು. ಲೈಕ್ x is equal to log raised to some value ಅತ್ತಿರತ್ತೆ, how you can solve, or E raised to some value ಅತ್ತಿರತ್ತೆ. ಸೊ ವೆರಿ ಸಿಂಪಲ್ ಟ್ರಿಕ್ಸ್ ತೊಗೊಂಡು ಅವ್ರು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಯಾರು. ಜಸ್ಟ್ ಟ್ರೈ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್. ಐ ನೋ ದಿಸ್ ಈಸ್ ವೆರಿ ಲೇಟ್, ಯಾಕಂದ್ರೆ ನಿಮ್ದು ನಾಳೆ ಎಕ್ಸಾಮ್ ಐತಿ. ಬಟ್ ಟಿಲ್ ದ ಲಾಸ್ಟ್ ಮೂಮೆಂಟ್ ಅವರ್ ರೆಸ್ಪಾನ್ಸಿಬಿಲಿಟಿ ಈಸ್ ಟು ಹೆಲ್ಪ್ ಯು. ಓಕೆ, ಸೊ ನಾವು ಯಾಕೆ ಇದ್ರದ್ದು ವೀಡಿಯೋ ಮೊದಲು ಮಾಡಿರಲಿಲ್ಲ ಅಂದರೆ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಅಲೌ ಮಾಡ್ತಾರೋ, ಅಗೇನ್ ವೈ ಟು ಕ್ರಿಯೇಟ್ ದ ಕನ್ಫ್ಯೂಷನ್ ಆರ್ ವೈ ವಿ ಹ್ಯಾವ್ ಟು ಪ್ರೊವೈಡ್ ಎಕ್ಸ್ಟ್ರಾ ಲರ್ನಿಂಗ್ ಫಾರ್ ದ ಸ್ಟೂಡೆಂಟ್ಸ್ ಅಂತಂದು. ಬಟ್ ಈಗ ಅಲೌ ಮಾಡೋದೇ ಇಲ್ಲ ಅಂದ ಕೂಡಲೇ ಈ ಟೈಪ್ ನೀವು ಕ್ವಶನ್ಸ್, ಯಾಕಂದ್ರೆ ನೋಡಿರಿ ನಾರ್ಮಲ್ ಕ್ವಶನ್ಸ್ ಅಂತೂ ಎಲ್ಲರೂ ಸಾಲ್ವ್ ಮಾಡ್ತಾರೋ. ಆ್ಯಂಡ್ ದ ಒನ್ ಹೂ ವಿಲ್ ಸಾಲ್ವ್ ದ ಕಾಂಪ್ಲೆಕ್ಸ್ ನ್ಯೂಮರಿಕಲ್ಸ್ ಅಲ್ಲ ಇನ್ ವೆರಿ ಲೆಸ್ ಟೈಮ್, ಸೊ ದ್ಯಾಟ್ ವಿಲ್ ಕ್ರಿಯೇಟ್ ಅ ಡಿಫ್ರೆನ್ಸ್ ಇನ್ ದ ಸಿಲೆಕ್ಷನ್ ಇನ್ ದಿಸ್ RWS AE. ಇಸಂಟ್ ಇಟ್? ಯಾಕಂದ್ರೆ ನಾನು ಮೊದಲಾದರೂ ಹೇಳಿದ್ನಿ ಇದ್ರೊಳಗೆ ಇಂಟರ್ವ್ಯೂ ಇಲ್ಲ. ಸೊ ಹೌ ಮಚ್ ಯು ಪರ್ಫಾರ್ಮ್ in this written test, that matters lot. So Anchit sir has put lot of efforts in framing this. ಯಾಕಂದ್ರೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ನಮಗೆ ಭಾಳ ಡೌಟ್ಸ್ ಕೇಳ್ತಿದ್ರು. ಅದನ್ನೆಲ್ಲ ಮೈಂಡ್ ಒಳಗೆ ಇಟ್ಕೊಂಡ ಯಾವ ಕ್ವಶನ್ಸ್ಗೆ ನೀವು ಹೆಂಗೆ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡ್ಬೇಕಂತಂದ ಅವ್ರ ಎಕ್ಸಾಂಪಲ್ಸ್ ತೊಗೊಂಡೇ ನಿಮ್ಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಯಾರು. ಓಕೆ, ಆ್ಯಂಡ್ ಅಗೇನ್ ವಾಟ್ ಐ ವಾಂಟ್ ಟು ಟೆಲ್ ಯೂಸ್, ಒನ್ಸ್ ಯು ಸ್ಟಾರ್ಟ್ ವಾಚಿಂಗ್ ದಿಸ್ ವಿಡಿಯೋ ಅಲ್ಲ ಅವ್ರ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ನು, ಸೊ ನಿಮಗೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಅನ್ನಿಸ್ಬೋದು. ಓಕೆ, ಇದೇನು ಮಾಡಲಿಪ್ಪ ನಾನು, ನಾಳೆ ಎಕ್ಸಾಮ್ ಐತಿ, ಇಟ್ಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್, ಲೆಟ್ ಮಿ ಸ್ಕಿಪ್, ಮಾರ್ಕ್ಸ್ ಹೋದ್ರೆ ಹೋಗಲಿ ಅಂತಂದು. ಸೊ ಎವ್ರಿ ಒನ್ ಫೀಲ್ ಲೈಕ್ ದ್ಯಾಟ್. ಓಕೆ, ಸೊ ಇಟ್ ಈಸ್ ನಾಟ್ ಜಸ್ಟ್ ಯುವರ್ ಪ್ರಾಬ್ಲಮ್. ಯಾಕಂದ್ರೆ ನಮಗೇನಾಗಿರುತ್ತೆ, ಲಾಗು ಎಕ್ಸ್ಪೋನೆಂಟ್ ಯಾವುದೋ ಫಾರ್ಮುಲಾ ಒಳಗೆ ಬಂದ ಕೂಡಲೇ ಸೊ ವಿ ಆರ್ ಟು ಯೂಸ್ ದ ಕ್ಯಾಲ್ಕುಲೇಟರ್. ಸೊ ನಾವು ಸಡನ್ನಾಗಿ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ತೊಗೊಂಡು ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ, ನಾವು ತಲೆನೂ ನಡೆಸೋದಿಲ್ಲ. ಇವನ್ ಲೈಕ್ log 10, log 1 ಸಿಂಪಲ್ ಇದ್ರೂ ನಾವು ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದಿಲ್ಲ. ಓಕೆ, ಬಟ್ ಈ ವಿಡಿಯೋ ಸರ್ ಏನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಯಾರಲ್ಲ, 2 ಹಿಡ್ದ 3 ಸಲ ನೋಡಿರಿ ನೀವು ಕಂಟಿನ್ಯೂಸ್. Okay, repeat and watch again and again 2-3 times. Definitely it will get fixed in your mind. Definitely try ಮಾಡ್ರಿ ನೀವು. And the video or the explanation is not lengthy, and I am 100% sure that this will add lot of value for tomorrow's exam. Don't skip it at any cost. Again I am telling you, ನಿಮ್ಗೆ ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಅನ್ನಿಸ್ಬೋದು ಅವ್ರ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಇನ್ ದ ಬಿಗಿನಿಂಗ್. 2-3 ಸಲ ನೋಡ್ರಿ. ಒನ್ಸ್ ಯು ಗೆಟ್ ಯೂಸ್ ಟು ಇಟ್, ಡೆಫಿನೆಟ್ಲಿ ಯು ವಿಲ್ ರಿಮೆಂಬರ್. ಸೊ ಅಗೇನ್ ನಿಮ್ದು ಮೈಂಡ್ ಒಳಗೆ ಮತ್ತೆ ಟ್ರಿಕ್ಸ್ ಬರೋದಿಲ್ಲ, ಅದನ್ನು ಬರೆಯಿರಿ. ಬಿಕಾಸ್ ಸಿ ದಿಸ್ ಲಾಗ್ ಆ್ಯಂಡ್ ಆಲ್, ಅಗೇನ್ ದಿಸ್ ವಿಲ್ ಬಿ ಹೆಲ್ಪಿಂಗ್ ಯು ಫಾರ್ ಅದರ್ ಸಬ್ಜೆಕ್ಟ್ಸ್ ಆಲ್ಸೋ ವೇರ್ ಲಾಗ್ ಆರ್ ನ್ಯಾಚುರಲ್ ಲಾಗ್ ಆರ್ ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ is involved. Okay, so again I am telling you, watch this video as well and today's video and perform really good in tomorrow's exam.
Hello everyone, here we are discussing the tricks that can be used in order to solve the numericals in the exam when the calculator is not allowed. So first of all, here you can see this is the log table where the values from log 1 to log 10 have been mentioned, and we need to remember these values. So log 1 value is equal to 0 and log 10 value is equal to 1. This we already know. But now here we need to remember the other values also. Like log 2 is equal to 0.3. Next one is log E is 0.434. We know that E value is 2.718. So when we take log of that, it comes out as 0.434. Next is log 3. The value is 0.48. Log 4 can be written in this way. Log 2 square. This is the property of the log, that whatever is in the power, that will be written in front. And here we are getting 2 log 2. And log 2 value we already know it is 0.3. So from here the value of log 4 comes out to be 0.6. Next one is log 5, whose value is 0.7. Next is log 6. Now here this log 6 can be written in this way. Log 2 into 3. The property of log is log AB can be written as log A plus log B. So log 2 value is 0.3 and log 3 value is 0.48. On adding these two, we are getting the value as 0.78. Next is log 7. Its value is 0.84. Next is log 8. Now here this 8 can be written as 2 cube. So this 3 will come in front, and then we have log 2. Log 2 value is again 0.3. So 0.3 into 3, the value comes out as 0.9. Next one is log 9. So 9 can be written as 3 square. So using property of log, this 2 will come in front. Log 3 value is 0.48. So twice of 0.48 gives us the value as 0.96. And finally the last one is log 10, whose value is 1. So if we clearly see all the values, they are lying between 0 and 1. And out of this, we need to remember only few values. The other can be derived. Like log 4 value we have derived using log 2 value. Same way log 6, log 8 and log 9. These values we can derive. So the values which we need to remember are log 2 value, log 3 value, log 5 value, log 7 value, and also log E value. So remember this table carefully. Using this log table, we are going to discuss some of the tricks using which we can solve the numericals in the exam. So let's discuss some of the tricks now. So here the first trick is that if we get this kind of situation, that x is equal to 10 raised to power n. Now this n can be anything. It can be integer value, it can be fraction, or it can be decimal value. So in such a situation, how we can obtain the value without using the calculator? Now here, before proceeding further, I am going to make an announcement that whatever tricks we are discussing here, these are going to give us the approximate answer. These will not be the exact answer, but will be very much closer to the exact answer only. So these tricks are going to be really helpful for us in the exam. So if we see this kind of pattern, then how to solve the numerical that we are discussing. So this we are going to understand with the help of certain examples. So first example is x is equal to 10 raised to power 3.48. So clearly it is in the format of x is equal to 10 raised to power n. Now how to solve this? So first what I am going to do is, I am writing the problem again, that x is equal to 10 raised to power 3.48. So my first step now will be, I will be writing my x is equal to 10 raised to power 3. What I have done, whatever is before the decimal, that I have considered as the power of 10. So simply I have written 10 raised to power 3. So simply you can say that we are considering only this much part. So this will be written as it is. And then I am going to write anti-log of 0.48. So whatever is remaining, it's anti-log we have to consider. And you must be wondering, we have seen the log table. Now what is this anti-log? Anti-log is basically the reverse of the log. So if I go back in this table, if I say that, what is anti-log of 0.3? So anti-log of 0.3 is basically equal to 2. Same way, another example we can take, anti-log of 0.7. So anti-log of 0.7 will be equal to 5. So basically the reverse of log is anti-log. One more example I am considering, 0.84 anti-log if we have to determine. So its anti-log will be equal to 7. So reverse of log is anti-log. So let's get back to our problem. So here now we need to compute what is anti-log of 0.48. So for this I will be taking the help of the table, and there we have seen that log 3 is equal to 0.48. Log 3 is equal to 0.48. So from here clearly I can say that the anti-log of 0.48 is equal to 3. So anti-log of 0.48 is equal to 3. Now I can substitute this value in this expression. So my answer will be x is equal to 10 raised to power 3 multiplied by the value of antilog is equal to 3. So this will be my answer. Now you may check also using the calculator whether whatever answer we are getting that is correct or not. So using the calculator we are going to get 10 raised to power 3.48. So this value is 3019.95. While the answer that we are getting here that is equal to 3000. So approximately we are getting the same answer. So this is how we are going to solve the problems where we are getting this kind of format. X is equal to 10 raised to power n. Let's solve one more numerical. Now here we have x is equal to 10 raised to power 6.15. So what I will be doing? I will be writing x is equal to 10 raised to power 6. So first I am considering this part. Multiply by antilog of whatever is there after the decimal. So antilog of 0.15. Now if I look into the log table, we don't have this value of 0.15 there. So how to find its antilog? So I know that log of 1 is equal to 0, and also I know that log of 2 that is equal to 0.3, and somewhere in between this 0 and 0.3 the value of 0.15 will lie. So 0.15 will be lying in between these two values. So by doing the interpolation we can obtain the antilog of 0.15. So basically this thing is unknown for us. This we have to determine. I can also write this thing in another way. I can write it as antilog of 0 is 1, antilog of 0.15, this is unknown for us, and antilog of 0.3 is equal to 2. So this unknown thing we have to determine. So how it will be determined? For that we will be doing the interpolation. So how we do interpolation? Now in this particular question, if I see this value 0.15, it is falling exactly in between 0 and 0.3. The middle value of 0 and 0.3 will be 0.15, or I can call it as average value also. So same way on the left hand side, here I have the value as 1 and this is 2. So here I can take average of these two values or the middle value. So middle value of 1 and 2 will be what? It will be 1.5. So here I have log of 1.5. So that unknown value will be 1.5. So this unknown value I am getting as 1.5. I can say that antilog of 0.15 is 1.5 approximately using this interpolation. You can also apply the formula of interpolation, that will be unknown value will be equal to 1 plus 2 minus 1 divided by 0.3 minus 0 multiply by 0.15 minus 0. This is the formula of interpolation using which we can determine the unknown value. So on solving from here also we are going to get 1.5. So basically what we have done here is we have seen that when we are moving from 1 to 2, this value is changing from 0 to 0.3. So same thing has been written 2 minus 1, 0.3 minus 0. But now here we have to move only from 0 to 0.15 so that we determine this unknown value. So here this value is written as 0.15 minus 0 because corresponding to this we are finding this difference. So this difference is coming out as 0.5, and when we add a 1 into that we are getting 1.5. I can also solve it by considering the unitary method. The unitary method says that when we are moving from 0 to 0.3, the change that we are observing is how much? The change is equal to 0.3. Same way when I am moving from 1 to 2, the change is how much? Change is equal to 1. 2 minus 1 is 1. So for 0.3, I am getting the change of 1. So for 1 unit, I will be getting the change of 1 upon 0.3. But in actual, how much I am moving? I am moving only from 0 to 0.15. So change is how much? 0.15. So for this 0.15, how much change I am going to observe here? That I want to determine. So that will be given as 1 upon 0.3 into 0.15. So this will come out as 0.5. And what was the initial value? The initial value was 1. So 1 plus this change 1.5. So now let's put the value in this expression. So here we have 10 raised to power 6. Antilog of 0.15 is 1.5. So from here I'm getting 1.5 into 10 raised to power 6, and this will be approximate value because here we are doing the interpolation. It won't be the exact answer, but it will be near to the exact answer only. Let's solve next problem. Now here, if I look carefully, this is basically x equal to 10 raised to power minus n. We have seen that for format of x equal to 10 raised to power n, how we solve it, but here I am considering minus n. So there is not much change here. What we do is, this can be written as 10 raised to power minus 5.3, which will be written as 1 upon 10 raised to power 5.3. So what I have done here, I have simply taken the reciprocal so that we can adjust this negative sign. Now in the next step, I will be doing same. X is equal to 1 upon 10 raised to power 5 will be written as it is. And then we have nt log of whatever is remaining after the decimal. So that is 0.3. Nt log of 0.3. So I'm solving, this comes out as 1 upon 10 raised to power 5. Now nt log of 0.3. So if I recall the log table, I know that log 2 is equal to 0.3. That means nt log of 0.3 is equal to 2. So this value is basically equal to 2. So from here I am going to get 0.5 into 10 raised to power 5, or I can also write it as 5 into 10 raised to power minus 6. And you can solve using the calculator also to check whether we are getting a closer answer or not. Let's move to our next problem now. So this is somewhat similar to previous one only. This is just for your practice. So here again I can write my x is equal to 1 upon 10 raised to power 2.7, because here again negative power is given to us. So we are taking reciprocal. So in next step I can write 1 upon 10 raised to power 2 multiply by nt log of 0.7. Now again, to obtain this nt log, we'll refer the log table. So from there I know this, that log of 5 is equal to 0.7. So nt log of 0.7 will be simply 5. So this is coming out as 0.2 into 10 raised to power minus 2, or I can say this is 2 into 10 raised to power minus 3. So this is the value of 10 raised to power minus 2.7. Now these kind of calculations you will generally find when we are solving the question of pH in the environmental engineering. There we generally get this kind of expression 10 raised to power minus n. And also when we are solving the questions related to BOD, there also you'll be finding that we have exponential powers. So there these kind of tricks will be quite handy for us. So now here next one is x is equal to 10 raised to power minus 3.8. So let's solve this one now. So here I'll be writing my x is equal to 1 upon 10 raised to power 3.8. Next step I can write this is 10 raised to power 3. Whatever is before decimal, that will be taken as power of 10. And then we have nt log of 0.8. Now in previous question we were having 0.7. So clearly from table we were getting the nt log of 0.7 as 5. But this 0.8 nt log, this value we cannot obtain from the table directly. So here we need to go for the interpolation. So here I'll be writing log 6 value is how much? Log 6 value is 0.78, and log 7 value is how much? Log 7 value is 0.84. So somewhere in between these two, 0.8 value will be lying. So I need to find this unknown value. Nt log of 0.8 will be this unknown value. How to find this unknown value? This we have seen just now. Using the formula we can find it. So I'll be writing 6 plus 7 minus 6 divided by 0.84 minus 0.78. So what I have done? I am seeing how much change is happening here. So change here is 7 minus 6. And how much is the change which is happening here? That is 0.84 minus 0.78. And this has to be multiplied by how much change we are seeing here. So this change is 0.8 minus 0.78. So this entire thing will tell me how much change is there. And initial value is how much? Initial value is 6. So we are adding 6 here. So let's find this value now. So on solving, this value will come out as 6.33. This value is coming out to be 6.33. So here I can say that nt log of 0.8 is 6.33. So let's substitute this value over here. So I'll be getting 1 upon 10 raised to power 3 into 6.33. So on solving this, we are going to obtain 0.157 into 10 raised to power minus 3. 0.157 into 10 raised to power minus 3, or I can write it as 1.57 into 10 raised to power minus 4. So this will be the value of 10 raised to power minus 3.8. Now coming to trick number 2. Now here we are having this kind of format. Earlier we were having x is equal to 10 raised to power n. Now suppose in place of 10 there is some other number. Then what can be done? Now this other number, again it can be fraction, it can be decimal or anything. So how to solve these kind of problems that we are discussing now. So here you can see this is the first problem. So here now we don't have 10, here we are having the value as 5. Now how to solve this? So first task here is we need to convert it into the format of 10 raised to power n. This will be our first task. So now how to convert this into format of x is equal to 10 raised to power n, that we are discussing first. So first step will be, we'll be taking log. Take log on both the sides. So after taking log, I'll be writing log of x is equal to log of 5 raised to power 0.8. So in the next step, let's simplify it further. So log x will be equal to, now I'm using the property of the log that whatever is in the power that can be written in front. So 0.8 into log 5. So from here I can write this is 0.8 multiplied by log 5 value is how much? That is 0.7. 8 7s are 56. So this will be 0.56. Now this is value of log x. This is not the value of x. Remember this. Whatever we have obtained, this is the value of log x. But in actual problem, we have to find the value of x. So how we can do that? Now I'm going to take anti-log. Initially what we have done, we have taken log. Now we are taking anti-log. So when we take anti-log, this will be written as x is equal to 10 raised to power 0.56. So now this has become same as the previous format. That is x is equal to 10 raised to power n. And it will be solved in the same manner. This we know how we can solve this. So this will be written as 10 raised to power 0, because before decimal we have 0, multiply by anti-log of 0.56. Now how to obtain anti-log of 0.56? So for that we'll be referring the log table. So in log table I know that the value of log 3 is 0.48 and the value of log 4 is 0.6. So somewhere in between these two, this 0.56 will be lying. It will be in between these two values. So I need to find this unknown value because we are finding here the anti-log. So this unknown value will be written in this way. This will be initial value, that is 3 plus. So how much is the change? 4 minus 3. This is the change that we are experiencing here. How much is the change here? That is 0.6 minus 0.48. And how much change is happening from here till here? That is 0.56 minus 0.48. So this we need to solve. So on solving, this will be 3 plus 1 divided by 0.12 multiply by, this will be 0.08. So this will be basically 2 by 3. 2 by 3 will be 0.66. 0.66 plus 3, that will be 3.66. That means anti-log of 0.56, that is equal to 3.66. So let's substitute this value. So x is equal to 10 raised to power 0 multiply by anti-log of 0.56, which is 3.66. And 10 raised to power 0 is basically 1. So x value comes out to be 3.66. So this way we can obtain the value of x in this case. So what we have done here in this case is, first we have converted it in the previous format, that is x is equal to 10 raised to power n format. So for that, first we'll be taking log on both the sides, and after that we'll be taking anti-log, and it will be solved in the similar way as we have solved the format of x is equal to 10 raised to power n. Let's solve few more problems. Now here again we have the format of x is equal to m raised to power n. Rather, I can say minus n. Let's see how this question will be solved. So first step will be, we need to convert it into the format of x is equal to 10 raised to power n. So for that, I'll be taking log on both the sides. So taking log on both the sides, we are going to obtain log x is equal to log of 9.5 raised to power minus 2.2. This is the first step. Now, further on simplifying, I'll be getting log x is equal to this minus 2.2. This I can bring here in front, and then I have log of 9.5. Now, what is the value of log 9.5? Let's determine that. So I know that log 9 is equal to how much? Log 9 is equal to 0.96. This I am writing from the log table which we have discussed initially. And log 10 also I know its value is equal to 1. So what will be log 9.5? So log 9.5 will be lying between these two, exactly at the middle. So the middle value of 9 and 10 is 9.5. So same way the middle value of 0.1 and 0.96 will be how much? That will be 0.98. You can also do it by the interpolation formula. Now this time this value is unknown for me. But here, since the value is falling in the middle, so directly I have solved this. So let's put the value now. So this will be log x is equal to minus 2.2 multiplied by 0.98. On simplifying this, we are getting minus 2.156. This is the value of log x. But we need to determine the value of x. So for that, we'll be taking anti-log on both the sides. So when we take anti-log, it will be written as x is equal to 10 raised to power minus 2.156. And this I can write as 1 upon 10 raised to power 2.156. So reciprocal has been taken to adjust the negative sign. Now, how to solve this? So x will be 1 upon whatever power is there before the decimal, that will be written as power of 10, and anti-log of remaining term we are going to take. So anti-log will of 0.156 I need to consider. So we know that log 1 is how much? Log 1 value is 0. Log 2 value is how much? That is 0.3. So 0.156 will be falling in between them. I can also consider it to be 0.15, which is the approximate value. So exactly it is falling in the middle. So this value will be how much? Log 1.5. So anti-log of 0.156 will be roughly 1.5. So let's put the values. So 1 upon 10 raised to power 2 into 1.5. So this will come out as 0.666 into 10 raised to power minus 2, or I can write it as 6.66 into 10 raised to power minus 3. So this is the approximate method to solve these kind of problems. Now here we have x is equal to e raised to power minus 9.2. Now this type of case will usually arise when we are solving the questions related to BOD. So there, how quickly we can find this value without using the calculator, that we need to understand. Now this is again the same format, that is x is equal to m raised to power n, or I can say it as minus n. So it will be solved in the same way as we are doing the previous questions. So first I'll be converting this into the format of x is equal to 10 raised to power n. So for that I need to take log on both the sides. So I'll be writing log of x is equal to log of e raised to power minus 9.2. On simplifying, I can write log x is equal to this power of minus 9.2 will come in front, and we are left with log of e. And this log of e we have seen in the table, its value is 0.434. So minus 9.2 into 0.434. So on solving this, I'm going to get the value as minus 3.9928. So roughly I can consider this value as minus 4. Now this value of minus 4, this is log x. What we need to find? We need to find the value of x. So for that, what I will be doing? I will be taking anti-log. Need to consider anti-log. So anti-log will be x is equal to 10 raised to power minus 4. Now here, no need to solve it further because 10 raised to power minus 4 is already in the simplified format. So here we'll be leaving our answer. So this is how we'll be solving the questions where we have the power of e. Now coming to trick number 3. Now you will be encountering certain questions where we need to compute the natural log of 1 minus x, and the x value is very small. So there we can simply consider this trick number 3. So it says that the natural log of 1 minus x is almost equal to minus x, provided the x is having a small value. So let's consider an example here. So suppose I'm considering that my x value is 0.2. So when I solve this, it should be minus 0.2. You can check using the calculator also whether whatever analysis we are doing here, it is correct or not. But make sure that this trick number 3, it will only work when the x value is small. If I further decrease the value of x, suppose I am considering ln of 1 minus 0.02, then my answer should be minus 0.02. So smaller is the value of the x, more accurate the answer we are going to get. So remember this trick number 3 also. Trick number 1 was when we are having this kind of condition, x is equal to 10 raised to power n, then how we can solve the problems. Then trick number 2 was when x is equal to m raised to power n, then how we need to do the analysis. And trick number 3 is when we are considering the natural log of 1 minus x, provided x is small, so it will be simply equal to minus x. Now let's move to trick number 4. Trick number 4 says that if we have 1 minus x raised to power n, then it can be simplified in this way, 1 minus n into x. So now let's see the application of this trick number 4. So here we have a numerical from the hydrology. So here we need to compute the return period which we need to adopt for the design of a bridge if only 5% of the risk of the flood is allowed in the entire design life of the bridge, and the design life is given as 25 years. So here n is 25, risk is given as 5%, which can be written as 0.05. So the formula goes like this: risk is equal to 1 minus p whole raised to power n, where p is the probability of occurrence of the flood. So from here we'll be finding what will be the return period, because I know that this p is equal to 1 upon t. So first we'll be computing the value of p, and then by taking the inverse we can compute the value of time period or return period. So let's put the values now. So risk is 0.05, 1 minus p. So p here is unknown, raised to power n. N is the design life which is given as 25. So let's solve this. So on simplifying this further, I can write 1 minus p raised to power 25 is equal to 0.95. On further simplifying, I will get 1 minus p is equal to 0.95 raised to power 1 by 25. Now this kind of expression we can solve only using the calculator. So from here I am going to obtain the value of p as 2.049 into 10 raised to power minus 3, and return period is a reciprocal of the probability, so 1 by p, so 1 upon 2.049 into 10 raised to power minus 3. So this comes out to be 488 years. So this is when the calculator is allowed. Now, if in exam calculator is not allowed, then how to solve this problem, that we are going to see. So here I am going to apply trick number 4. So let's see that. So I will be writing risk is equal to 1 minus p raised to power n. Risk value was 0.05. 1 minus, so p I can write it as 1 by t, and here we have power as 25. Now in the next step I can write 1 minus 1 by t raised to power 25 is equal to 0.95. Now I'll be applying the trick number 4, which says that 1 minus x raised to power n can be written as 1 minus nx. So 1 minus, in our case n is 25, x is 1 by t, which will be written as it is equal to 0.95. So from here I'll be getting 25 upon t is equal to 0.05, and t value will be 500 years. So the actual calculation says that t is equal to 488 years. But approximately we can use the trick number 4 and we can obtain the value of t, which is coming out as 500 years. So approximate value we are obtaining here, which will definitely help us in the exam to mark the correct answer. So these were some of the basic tricks which one should know before going into the exam. So whether the calculator is allowed or not allowed in the exam, you should be in a position to solve the numericals. So I feel whatever tricks which we have discussed here, that will be beneficial for you in the exams. I wish you all good luck.